Okay, so we're going to use our same problem. We've solved this in the prior two videos. We've solved it using present worth, and we found out the present worth was positive at the stated minimum attractive rate of return of 15%. So we knew that it was a project worth doing, and we were making more than 15% on it. And we found that we would be willing to invest $352,000 more than our initial investments, because that's how positive our present worth was. Then we also solved for annual worth, which is another measure of profitability, and we saw that the annual worth was positive, was $70,000 a year. So again, annual worth is positive. That tells us that we're making more than the minimum accepted rate of return, and therefore we would be willing to go forward with the project. Because both present worth and annual worth, and future worth also, are measures of profitability, the decision will always be the same. It will always be, if one method tells you to move forward with the project, then the other methods will as well. But we don't know what exactly is our internal rate of return, and I'll define that for you in a minute as well. So that's what we're going to do now. We're going to take the same problem and we're going to find what is the internal rate of return. What is the rate of return? What percent return are we getting on this investment? We know it's greater than 15% because we're positive. Both our present worth and our annual worth are positive, so we know it's higher than 15%. But exactly what is it, and how do we figure that out? So we do the same thing here. We start off with our cash flow diagram is always our friend, so it looks just like it did before. But now, instead of trying to find the present worth or the annual worth of equivalent of these cash flows, we are going to find the internal rate of return. And one way of saying a description of the internal rate of return is the interest rate at which the present worth, it could be annual worth or future worth, of the cash flow is zero. So present worth of benefits equals present worth of costs is one way. The interest rate at which present worth of benefits equals present worth of costs. Or another way of saying it is the interest rate at which present worth of benefits minus present worth of costs equals zero. So we know then that our known factor is present worth. If we want to find the internal rate of return, our present worth is zero. So you can see I've got it set up here. Present worth equals zero. And it's the same formulation as we saw in the prior ones, and especially in the present worth solution. So we have all of our costs. So the sum of all of these is the negative outflow of 1.25 million, 1,250K, plus, and that's already at the present, so I don't need to do anything with that, plus 750, which is my positive annuity, my revenue coming in. I want to find the present given that annuity, but now I don't know what the interest rate is, so I have to leave that blank, and my unknown is I%, but it's still over 10 years. And then I'll subtract out my cost annuity of 475. Again, I'm finding the present given the annuity, but I don't know what the interest rate is. I know that it's over 10 years, but I don't know what that interest rate is that is going to make this cash flow equivalency be zero at times zero at present worth. And then my last one is my salvage values out here, which total up to 900. I want to find the present given the future, again at the stated interest rate that I'm not sure what this is yet, over 10 years. But whatever interest rate I choose is going to be here. It's going to be the same in all of them, just like it was 15% in all the others. It's going to be something that is going to make this cash flow stream be zero instead of the $352,000 it was when we used the 15% MAR. So if you're in Excel, it's very easy to do it. It's a function just equal IRR over the cash flow stream, but we're not in Excel, and you're not going to have Excel on an exam. So basically, we just have to chug and plug different interest rates that make the present worth zero. So as we've said, we know that when present worth is greater than zero, present worth was greater than zero when we use 15%, so we know we're making more than 15%. So let's just try 20% for kicks. So what we're going to do then is we want present worth equals zero, and does it equal zero when the interest rate is 20%? So you see how my same thing, I'm turning my present worth of cost stays the same. I have my annuity that I'm going to convert to present worth using 20%. I have my cost annuity I'm going to convert to present worth using 20%. And I have my single payment on my salvage value that I'm going to convert to the present using 20%. So I just find the factors in the table again. Compound tables, go to the 20% page. Find the present given the annuity over 10 years, and then multiply these all out. And the present worth equals $48,000. So when the interest rate is 20%, the present worth of this cash flow stream is $48,000. $352,000, so a lot less than the $352,000, but still not zero. So even at a 20% interest rate, we're still making money. We're making $48K. So we know it's greater than, we know the internal rate of return, the rate of return at which this cash flow stream has a present worth of zero. We know it's greater than 20% because we're still making money at 20%. So again, I'm using the functional notation. I use the tables that are in Appendix C in your book. You're more than welcome to use the formulas. You just plug in 20% for the I, 10 for the N, and the find the present, give the annuity formula. You can find these in the front cover of your book and also in Chapter 4. But I'm using the tables. So because I'm using the tables, my only choice right now is to jump up to 25% because that's the next table. So more than likely, we're going to cross the threshold here, but let's work it through and see. So again, when interest rate was 20%, the present worth was positive, so we know that we're returning more than 20% because we still have a positive present worth, so we're jumping up to 25. So same criteria, same process as before. We have all our costs at time zero. We have our revenue annuity that we are going to bring to the present using 25%. We have our cost annuity that we are going to bring to the present using 25%. And we have our salvage values, our single payment out in the future that we are going to bring to the present using 25%. So again, I go to the table and I find these values. And when I multiply that all out, I see it's negative $171,000. So obviously now I've crossed the threshold. The internal rate of return is somewhere between 20 and 25. Now, on an exam or a quiz, I would be perfectly fine with you saying that the internal rate of return is slightly greater than 20% for this particular problem. That would be perfectly fine. You can also use interpolation between the two and find out exactly what it is. I'm not going to do that right now, but you could do that. And that is that. So that's how we find internal rate of return. Unfortunately, we just have to plug and chug until we find the present worth equals zero or very close to it. All right, I hope that's clear, and we'll be working out some more problems too, but that's the internal rate of return. So we found out the present worth of this project at the MAR of 15% was $352,000, and then we've just found out that our internal rate of return, the interest rate at which this cash flow stream has an equivalent present worth of zero, is slightly greater than 20%. Thank you.